Thank you for joining this lesson. We're going to study quantity of heat. In part C, figure 9 shows one method of measuring the specific latent heat of fusion of ice. Two funnels, A and B, contain crushed ice at 0 degrees Celsius. We are determining a specific latent heat of fusion of ice. And it's good to, first of all, understand what specific latent heat of fusion of a substance is. And this is the amount of heat energy that is required to change a unit mass of a substance from solid to liquid at a constant temperature. So we are told there is a funnel A containing crushed ice, a funnel B also with crushed ice, but now in B there is immersion heater whose power is 24 watts. We are further given more instructions that the mass of melted ice from each funnel is measured after 11 minutes, very sensitive. The results are shown below. So we are having mass of melted ice in B, 24 grams, mass of melted ice in B, 63, in A, 24. What is the reason for setting up funnel A? And we should know that the purpose of funnel A is what we call a control experiment. It's a control experiment. In other words, it will be here to tell us, what if there was no immersion heater? Are we not realizing that ice could still have melted naturally? Yes. So it's a control experiment. Then we are determining the part 1, quantity of heat supplied by the heater. Quantity of heat supplied by heater. Remember, this is an electrical heater. It is already having a given power, which is 24, and it's going to operate for 11 minutes. So we should know that electrical energy, which anyway becomes the heat energy, is usually given by power times time. So the power is 24 watts multiplied by time, which has to be made in SI units. So because it's 11 minutes, now we multiply with 60 to get time in SI units. So this is going to be 24 by 11, then multiplied by 60. This is going to be 15,840. 15,840 joules. So this heater is going to supply energy equivalent to that value. The next is the mass of ice melted by the heater. So mass of ice will be given by the mass in B minus the mass in A. This is going to be 63 minus 24. This is going to be 63 minus 24. This gives us exactly 39 grams. That is the mass of ice melted by heater. Because in A there is no heater and 24 grams have melted, which means in B there is an equivalent mass which has melted naturally. So the mass which is melting specifically due to the immersion of the heater is the difference. That's why I'm subtracting 63 and 24. Then we are having finally here, determine the specific latent heat of fusion of ice. So for us to know specific latent heat of ice, we should know that for us to get the heat energy required in any process for change of energy to take place, that is a latent heat of vaporization, is usually given by mass multiplied by latent heat of fusion. So we should say that latent heat of fusion is given by mass times specific latent heat of fusion. Therefore, the heat energy required, we can even say the heat energy, H, the heat energy required in the process of changing the state of ice into water is given by mass of the ice that will be converted multiplied by specific latent heat of fusion of ice. And therefore, the heat energy which has been required in the absorption process is the heat energy which has been supplied by the heater, and the value is already calculated here. Therefore, the value of heat energy, 15,840, this is equivalent to the mass, which is 39 as obtained there. We can make it SI units. Then we multiply by their known latent heat of fusion. Therefore, latent heat of fusion equals to, when we take 15,840, we can first multiply by 1,000, then we divide by 39, and this is going to give us 406, 153.85, and this is usually, because it is at a constant temperature, it's joules per kilogram, and not per Kelvin, joules per kilogram.